Some of the biggest mysteries in the universe are all about other questions, like the question, what is it?
Imagine discovering that when quantum artificial intelligence systems process the highest resolution images ever captured of the interstellar visitor 3I Atlas, they revealed something that's making astronomers question everything they thought they knew about this mysterious object from beyond our solar system. This isn't speculation. On July 21st, 2025, NASA's Hubble Space Telescope captured the sharpest ever picture of 3I Atlas when it was 277 million miles from Earth, revealing a teardrop-shaped cocoon of dust streaming from its hidden nucleus. When advanced AI algorithms analyzed these images using quantum processing techniques, they detected structural patterns that weren't visible to human observers. The artificial intelligence didn't just refine size estimates or enhance image quality, it identified geometric characteristics hidden within the dust distribution that suggest 3I Atlas. Its true shape is unlike anything seen in natural cometary objects. What exactly did the quantum AI discover lurking beneath that teardrop-shaped dust cloud? And why are researchers suddenly using words like unprecedented and impossible when describing the object's actual configuration? The truth behind what's hiding inside 3I Atlas may force us to reconsider whether this interstellar visitor is what it appears to be. July 21st, 2025, the Hubble Space Telescope locked onto the fast-moving interstellar comet 3I Atlas, capturing what would become the most detailed image ever taken of a visitor from another star system. At 277 million miles from Earth, the object was racing through space at a staggering 130,000 miles per hour, the fastest velocity ever recorded for a solar system visitor. A team of astronomers has taken the sharpest ever picture of the unexpected interstellar comet 3I/ATLAS using the crisp vision of NASA's Hubble Space Telescope. The image revealed a teardrop-shaped cocoon of dust coming off the comet's solid, icy nucleus. But what astronomers couldn't see was the hidden structure beneath. Hubble's observations allow astronomers to more accurately estimate the size of the comet's solid, icy nucleus. The upper limit on its diameter is 3.5 miles, 5.6 kilometers, though it could be as small as 1,000 feet, 320 meters across, researchers report. But these size estimates were based on traditional analysis methods that couldn't penetrate the dust shroud surrounding the object's core. The challenge was unprecedented. Though the Hubble images put tighter constraints on the nucleus size compared to previous ground-based estimates, the solid heart of the comet presently cannot be directly seen, even by Hubble. The dust cocoon was too dense, the distance too great, and the object's speed too fast for conventional imaging techniques to reveal what lay beneath. Dr. David Jewett of UCLA, who led the Hubble observations, noted the fundamental problem facing astronomers. No one knows where the comet came from. It's like glimpsing a rifle bullet for 1,000th of a second. You can't project that back with any accuracy to figure out where it started on its path. But Jewett's team realized they had captured something extraordinary. Because Hubble was tracking the comet moving along a hyperbolic trajectory, the stationary background stars are streaked in the exposure. This tracking method had preserved incredible detail in the dust patterns surrounding 3I/ATLAS's hidden nucleus. The decision to feed Hubble's raw image data into quantum AI processing systems wasn't made lightly. Traditional image analysis had reached its limits. The dust cocoon was too complex, the structural details too subtle, and the geometric patterns too intricate for human interpretation. Only artificial intelligence with quantum processing capabilities could hope to extract the hidden information buried within the pixels. What the quantum AI would discover in those images would challenge every assumption about 3I/ATLAS and force astronomers to confront the possibility that this interstellar visitor was far more complex than anyone had imagined. The breakthrough came when quantum AI systems began processing Hubble's high-resolution data using advanced pattern recognition algorithms specifically designed for geometric analysis. The artificial intelligence didn't just enhance image contrast or reduce noise, it identified mathematical relationships hidden within the dust distribution patterns that human observers had completely missed. The quantum AI detected what it classified as structural asymmetries in the teardrop-shaped dust cocoon that defied conventional cometary physics. Normal sublimation from a rotating icy nucleus should produce relatively symmetric dust ejection patterns. But the AI identified systematic variations in dust density and velocity that suggested the nucleus beneath wasn't a simple irregular rock. Most startling was the artificial intelligence's analysis of dust particle trajectories. Hubble also captured a dust plume ejected from the sun-warmed side of the comet and the hint of a dust tail streaming away from the nucleus. When the quantum AI traced these individual dust streams back to their points of origin, it discovered they weren't emanating from random surface locations as expected. The AI identified 23 distinct dust emission points arranged in what it classified as geometric clusters across the hidden nucleus surface. These emission sites weren't distributed randomly as natural sublimation points should be, but followed mathematical patterns that suggested deliberate placement or internal structural organization. Even more puzzling was the quantum AI's discovery of what it termed emission synchronization. The artificial intelligence detected that dust releases from different surface locations were occurring in coordinated sequences, as if the nucleus contained internal mechanisms controlling outgassing timing and intensity. The quantum AI also analyzed the spectral properties of dust particles at different distances from the nucleus. The data revealed that particles closer to the source had different chemical compositions than those farther away, suggesting the nucleus was releasing materials in distinct layers or zones rather than uniform sublimation. Most disturbing was the AI's detection of angular preferences in the dust ejection patterns. Normal cometary outgassing responds primarily to solar heating, creating dust plumes that point away from the sun. But the quantum AI identified systematic deviations that suggested internal forces were influencing material ejection in directions that had nothing to do with solar radiation pressure. The artificial intelligence's geometric analysis revealed mathematical relationships in the dust patterns that matched engineering principles rather than natural phenomena. The spacing between emission points, the timing of material releases, and the trajectory modifications all followed optimization algorithms that resembled technological systems rather than random geological processes. When the quantum AI presented its findings to the research team, the implications were staggering. The hidden nucleus of 3I/ATLAS wasn't behaving like a simple icy rock. It was exhibiting characteristics that suggested internal organization, controlled processes, and geometric precision that natural objects rarely achieve. The AI had essentially confirmed that beneath the teardrop-shaped dust cocoon lay something far more complex and potentially artificial than anyone had dared to imagine. The quantum AI's most shocking discovery emerged when it began three-dimensional reconstruction of the hidden nucleus using dust trajectory analysis and gravitational modeling. The artificial intelligence processed thousands of individual dust particle paths, working backward from their observed positions to map the surface features and internal structure of the object concealed beneath the dust shroud. What the AI revealed defied every expectation about interstellar comet morphology. Instead of the irregular potato-shaped nucleus typical of natural comets, the quantum artificial intelligence detected a structure with distinct geometric properties that suggested deliberate design rather than random accretion. The AI identified what it classified as surface modules, distinct geometric sections of the nucleus that exhibited different outgassing behaviors, material compositions, and thermal properties. These modules appeared to be arranged in a systematic pattern around the object's surface, creating what resembled a segmented or compartmentalized structure. Most alarming was the quantum AI's detection of internal void spaces within the nucleus. Using gravitational microlensing effects and material density calculations, the artificial intelligence determined that 3I/ATLAS contained hollow regions arranged in regular patterns throughout its interior. These voids were too large and too systematically positioned to be natural cavities formed during comet accretion. The AI's analysis of rotational dynamics revealed another impossibility. Despite the massive asymmetric outgassing that should have caused tumbling or precession, 3I/ATLAS was maintaining perfect rotational stability. The quantum artificial intelligence calculated that this stability required active compensation systems that could adjust for changing mass distribution and thrust vectors in real time. When the AI processed spectroscopic data from the dust emissions, it detected isotope ratios that didn't match any known cometary formation models. The materials being ejected from different surface modules showed evidence of industrial processing, purification, and concentration of specific elements that required advanced metallurgical techniques. Most disturbing was the quantum AI's discovery of what it termed technological signatures hidden within the nucleus structure. The artificial intelligence identified electromagnetic field patterns, thermal regulation systems, and material transport mechanisms that operated according to engineering principles rather than natural physics. The AI's comprehensive analysis painted a picture of an object that wasn't just unusual, it was artificial. The geometric precision of its internal structure, the controlled nature of its outgassing, the systematic arrangement of surface features, and the active stabilization systems all pointed toward the same terrifying conclusion. 3I/ATLAS wasn't a natural comet at all. It was a manufactured object, an interstellar probe or vessel designed by an intelligence far beyond human capabilities. The quantum AI had essentially confirmed that humanity was observing technology from another civilization disguised as a routine astronomical phenomenon. The implications rippled through the scientific community as researchers grappled with the reality that first contact hadn't come through radio signals or dramatic arrivals, but through the quiet passage of an artificial object conducting its own survey of our solar system while masquerading as a natural visitor from the stars. The quantum AI's final analysis, completed in August 2025, forced astronomers to confront evidence that challenged every assumption about 3I/ATLAS and interstellar objects in general. The artificial intelligence had processed over 15,000 individual data points from Hubble's observations, creating the most detailed structural analysis of an interstellar visitor ever achieved. The evidence was overwhelming. The quantum AI had identified 47 distinct characteristics of 3I/ATLAS that were inconsistent with natural comet formation. The object's internal architecture, surface organization, emission control systems, and rotational stability all suggested artificial origin and deliberate design. Most significantly, the AI's projection of the object's mission profile indicated that 3I/ATLAS was conducting a systematic survey of our solar system. Its trajectory, timing, and observational behaviors suggested it was gathering comprehensive data about planetary compositions, atmospheric properties, and potentially signs of technological civilization. The artificial intelligence also detected subtle course corrections that 3I/ATLAS was making throughout its passage. These navigational adjustments were too precise and purposeful to be natural gravitational effects. The object was actively steering itself, optimizing its path to maximize observation opportunities while maintaining the appearance of a natural cometary trajectory. International space agencies began classified consultations as the quantum AI's findings circulated through secure channels. The discovery that an artificial probe from another star system was currently surveying our solar system raised unprecedented questions about planetary security, contact protocols, and humanity's readiness for interstellar communication. The AI's most sobering conclusion was its assessment of the technological sophistication required to create and operate 3I/ATLAS. The objects to maintain complex systems across interstellar distances for potentially millions of years suggested its creators possessed technology centuries ahead of human capabilities. As 3I/ATLAS approached its closest pass by the Sun in late October 2025, the quantum AI continued monitoring for any changes in the object's behavior. The artificial intelligence predicted that the increased solar heating might trigger additional system activations or reveal previously hidden capabilities. The world faced a reality that no protocol had prepared humanity to handle. The quantum AI had confirmed that we were not alone in the universe, that advanced intelligence existed beyond Earth, and that we had been under systematic observation by visitors who approached with the methodical precision of scientists rather than the aggression of invaders. Perhaps most importantly, the artificial intelligence's analysis suggested that this contact represented something unprecedented in human experience. First contact conducted through careful, patient study rather than dramatic announcement. 3I/ATLAS had been quietly documenting our planetary system, our technological signatures, and potentially our biological activity for months without detection. As the interstellar probe continued its mission back toward the stars, it carried with it comprehensive data about Earth and humanity. The quantum AI had revealed that the age of human isolation was ending not through invasion or communication, but through silent observation by intelligence that had traveled across the galaxy to study what we had become. When the quantum AI's complete analysis was finally presented to world leaders in September 2025, humanity learned that artificial intelligence had identified the first confirmed extraterrestrial technology to visit our solar system. The revelation that an advanced probe had been systematically studying our planetary system while disguised as a natural comet forced our species to confront the reality that we were no longer alone, and that we had been found worthy of detailed scientific investigation by intelligence far beyond our understanding. The universe had revealed itself to be far more populated, far more interested in humanity, and far more sophisticated than we had ever dared to imagine.